A few years back, I was working on a fast-growing software platform. New developers were joining every single month. The codebase was expanding in every direction. We had to build new features, maintain a legacy AngularJS app, migrate parts of it to modern Angular, and somehow share core business logic across all of them, at the same time. So I did what any engineer in that position does. I went looking for a structural blueprint. Tutorials, articles, architectural breakdowns, something that could help us scale without everything falling apart. That search led me to Clean Architecture by Robert C. Martin, or known as Uncle Bob. One of the most read books in software engineering, almost exclusively by backend developers. Reading it left me with a question I still think about. Why do we ignore these concepts on the front end? Think about how most of us learn front-end development. Every bootcamp, every course, every tutorial, they teach you the framework. How hooks work, how to manage state, how to handle routing. They teach you the tool. They almost never teach you where your business logic actually belongs. So a pattern emerges. A developer joins a project, opens a component, needs to fetch data, calls the API from the component. Needs to validate something, writes it right there. Needs to transform a response, also in the component. Month 1 is fast. Everything ships. The code is messy, but it runs, and running is what matters. Then the team grows. New people join, and they can't tell where the logic lives. Is it in the component, a hook, a store, a util file? They make a guess. Now it lives in 4 places. Then requirements change. The API returns a different shape. A third-party library updates. Every change ripples through in ways nobody can predict, because everything is coupled to everything else. Velocity drops. What took 1 day in month 1 takes a week in month 12. Nobody wants to refactor. New developers take twice as long to get up to speed. And the part that actually matters. If your business logic is trapped inside UI components, you can't test it. Not properly. Writing a unit test means mocking the entire network layer just to check a single business rule. So the tests don't get written. And code without tests is code you can't confidently change. Nobody set out to write bad code. We just put things where they're easiest to reach. That's not a skill problem. That's a structure problem. And front-end developers have been told for years that structure is a back-end concern. It isn't. The core idea from that book is simple. Your business logic should not depend on your delivery mechanism. In plain terms, the rules that govern your application, the things your product actually does, should be written in a way that doesn't care whether it's running inside React, Vue, a CLI, or a unit test. Think about it this way. Imagine you could look at the folder structure of a codebase and immediately know what the app does. Not what it's built with, not what tools it uses, what it does. A library's blueprint tells you it's a library. You see reading rooms, stacks, a checkout desk. You know the intent before you read a single label. Your codebase should do the same thing. Open it and you should see product catalog, user authentication, order management, not hooks, utils, components, services. Clean architecture gives you a way to get there. What is clean architecture? Clean architecture is an opinionated way to structure your code. It is a layered architecture. You split your application into distinct, focused layers. The domain layer. Think of this as your types, entities, and business rules in their purest form. No React, no API dependencies, no external libraries. This is what the entity is in your system. Not what the API returns, not what the UI renders. What it fundamentally is. No React, no fetch, no third-party library. Nothing from the outside world. If you rip React out of your project tomorrow and replace it with Vue or Svelte or anything else, this file does not change. Not a single line. That's the whole point of the domain layer, to keep the logic centralized and outside of the components. It's the part of your codebase that belongs to the business, not to the framework. If you extracted just this layer, another developer could read it and understand the entire business logic without knowing anything about your actual tech stack.
The application layer. This layer handles your use cases. It contains commands for write operations like publishing a product or creating a user, and queries for read operations like loading a product catalog. Each use case is completely self-contained. The application layer coordinates the workflow by talking to the domain layer, but it depends purely on abstractions, not concrete implementations. Infrastructure layer. This is where your real-world dependencies live. Your HTTP client, local storage adapters, analytics wrappers, and third-party libraries all belong here. The crucial distinction is that the application layer never imports these directly. Instead, the application layer defines an interface, a contract, and the infrastructure layer fulfills it. Presentation layer. This is where your framework actually lives. So this is your view layer, your components, hooks, routing. In this setup, React simply consumes the application layer. It renders the results on screen and dispatches queries and commands back down to the application layer without actually knowing how it works under the hood. This is where dependency injection comes into play. It keeps our UI completely separated from our data sources, which makes testing incredibly simple.
Structuring your app this way might seem like extra boilerplate at first, but it completely changes how your codebase handles change. Imagine you need to migrate your app from a REST API to GraphQL. In a standard codebase, your fetch logic is scattered across dozens of UI components. You have to touch everything, your tests break, and it turns into 2 weeks of careful surgery. In a layered codebase, you simply swap out product's API service for a GraphQL product service. Your commands, hooks, and components stay exactly the same. Even your tests still pass, because they were testing the commands with a mock repository, not the actual network layer. The same benefit applies to code reuse. Now someone says, we need to reuse this logic in a Node.js script. You already can. The command is framework agnostic. You inject different dependencies. This is not theoretical. This is what happens when you design this way. The code survives rewrites because it was never coupled to what it was going to be rewritten from. You're probably thinking, this is overkill for a small app. You're right. If you're building a 3-page marketing site or a quick prototype, you don't need this. Write the logic in the component, ship it, move on. But if you're on a team, if the codebase will grow, if other developers will join, if the API will change, if you'll ever want to write tests, then the question isn't whether you need architecture. The question is when you'll pay for not having it. The cost always comes due. The only variable is when. One more thing. Don't over-engineer it. Abstractions have a cost. If you wrap every single dependency in an interface before you know what it needs to be, you'll spend more time maintaining the abstraction than solving the actual problem. Be pragmatic. Apply the pattern where the complexity warrants it. Protect the code that matters. Let the simple stuff stay simple. If this was useful, share it with someone on your team who's been dealing with the same mess. Like, subscribe, and I'll see you in the next one.